what you would see on your test. Okay, so first of all, we've already worked with a Taylor series, okay, and this is the Taylor series formula that we've already worked with. And remember, the way this kind of goes is you have this part right here is the linear approximation, okay? Then this term here gives you a quadratic approximation, then a cubic approximation, and so forth when you put that all together, okay? So that series is written by, what it's saying is the series k equals 0 to infinity. That represents a derivative. When I say f superscript k, that's talking about a derivative, okay? So the derivatives go up, we know that. And then we have x minus a to the second, third, fourth power, and so forth like that over k factorial. So we've already learned that. Now, what a Maclaurin series is, it just means that that it's centered at 0. In this formula, the center is A. Okay, the center is always A. So that means in a Maclaurin series, A is going to be equal to 0. So if I ask for a Maclaurin series, what you need to know is, okay, you're really doing a Taylor series, but the center is 0. That's what you know, okay? So we're going to write out a couple of these things. I'm going to go on down to this number 12 here and just kind of work this out. So what this one is saying, this is one I've taken out of the book. It says you're going to write the first 4 non-zero terms of a Maclaurin series for this function. Then you're going to write the power series using summation notation. And then you're going to do the interval of convergence. This is the kind of thing I expect you to be able to do on an exam. So this is a pretty good example of this, okay? So to begin with, what you want to do on this, if you're doing a Taylor series, you do derivatives, right? So if you look up here at your formula, if we're going to do the first 4 terms, well, you're going to have to just have the function value represented by a. In a Maclaurin series, what's a? 0. That's super important. Then you're going to do the first derivative, right? Then second derivative and third derivative. So if you're doing 4 terms, you need to do 3 derivatives, okay, like that. That's term number 1 is the function. Then f prime, f double prime, f triple prime, like that. So it makes a lot of sense on this problem to just start the problem this way. Okay, f of x is equal to ln of 1 plus 4x, like that. And while we're at it, we need to just go ahead and do f of 0. Why f of 0? Because it's a Maclaurin series. That's the center. So we're going to do ln of 1 plus 4 times 0. So that's equal to ln of 1. So that's equal to 0. That is your first term in your Maclaurin series. Now, the thing on this was, if you read the directions to the problem, now it says do the first 4 non-zero terms. So that one isn't going to count. So now we're going to have to do 4 derivatives, okay? Because that's the directions to the problem. That's a 0 term, so forget it. So we need to go on to 4 derivatives. Does that make sense? Okay? We've got to keep doing a derivative until we get a non-zero term. Okay, now let's go on to f prime of x. Okay, so let's do that. Real simple. This is a natural logarithm, so that's 1 over the function times the derivative of the function. Okay, so that's going to just be equal to 4 over 1 plus 4x. The reason we're doing that is now we need to evaluate that derivative. We need to really do f prime of 0 like the Taylor series tells us to do. So what we're going to do is we're going to do 4 over 1 plus 4 times 0. So that looks like that's going to be 4 over 1, or that's going to be 4. Okay, so that's the first non-zero term. Okay, so that would be the first term in our Maclaurin series right there. Okay, you're going to write the first 4 terms out. Okay, let's keep going. All right, so what we're going to do in some of these things, the derivatives, I'm going to write down the results on some of these. So if I go on to f double prime, well, if you do this, and I'm just going to do this at the side, then I'm just going to kind of start writing some of these things down because I'm confident you could do these derivatives, okay? So if you were differentiating this thing, you could do a quotient rule or you could just do a chain rule. What I would do is I would just write this as 4 times 1 plus 4x to the negative 1, okay? To me, it's easier to do that than it is the quotient rule. So if you did this, you're going to get negative 4, 1 plus 4x to the negative 2, And then the derivative of what's inside, the derivative of 4x is 4. So that's negative 16 times 1 plus 4x to the negative 2 power. Okay, that's what that is. So you can just kind of do that at the side of your paper. And this is something you would do on an exam. So f double prime is negative 16 over 1 plus 4x to the second, like that. Okay, then we got that. All right, so that should be a pretty simple derivative. Now what do you need to do? You need to evaluate that derivative at 0. Okay, so you need to get that done. All right. So now what we're going to go through and do is we've got this. We have negative 16 over 1 plus 4 times 0 to the second. Okay, if you work that out, that looks like negative 16 over 1. So that's negative 16. Okay, so that would be your second term then, like that. Okay, and this shouldn't be that hard to do because the derivatives are fairly simple, and then there's the arithmetic involved. Okay, is everybody with me so far? Okay, all right. We oftentimes do a problem like this on a final exam too, okay? Just kind of a straightforward knowledge of what a Maclaurin series is, how to write things out. Okay, now what I'm going to do is I'm going to go on to f triple prime. Now this time, to save time, you would be able to do that derivative again. I'm confident you would, but if you do the third derivative, you're going to get 128, 1 plus 4x to the negative 3. And while we're at it, let's go ahead and write the fourth derivative. Fourth derivative, you usually put parenthesis 4, and if you did that, you would get negative 1536, 1 plus 4x to the negative 4, like that. I don't want to bog down in time with doing those derivatives because you should be able to do that fine. Okay? So we do need to go through and evaluate these things. So if we do the third derivative at 0, that's going to just be 128 over 1 plus 4 times 0 to the third. So if you work that out, you're going to get 128. Okay, like that. So now we got 3 terms. So we're getting close to being able to do this. Now these are not the complete term. They are the coefficients that show up in the Maclaurin series. Okay, let's now do f4 of 0. So that's going to be negative 1536. You're going to begin to see how to get the answer by now. The answer is just turning out to be that constant on this, okay? So if you do that, you're going to get negative 1536, like that. Now I'm going through that arithmetic pretty quick, but that shouldn't be too big of a problem area. Okay, so what I did so far is it's a Maclaurin series. That's why I am centering it at 0. And I'm doing 4 derivatives, okay? We wanted 4 non-zero terms. The first one turned out to be 0, so we ignored that. So now what we're going to do is we're going to go ahead and we got to build that. We got to find the first 4 non-zero terms of the Maclaurin series. So it basically goes like this. If you look at your formula, it would go like this. The f of 0, that was already this term. Now I'm going to go ahead and write this in just for emphasis. And then it follows a nice pattern. Okay, that's your constant term, like that. Then if you look at your formula, the next, what are you doing? You're doing the first derivative times x minus a to the first. Then what are you doing? Second derivative over 2 factorial x minus a to the second. It's actually a very easy structure to remember. So let's see if we can put this together now. So that's your first term. I'm not going to write that in my answer, but just to get you started, I'm going to. So now this one's going to be 4. This is your second term. So it's going to be 4 times x minus 0 to the first, like that. Okay? Then once we get to the quadratic term, what do? We do negative 16. So I'm going to go ahead and just write this as minus 16. Then what do we have? X minus 0 to what power? Second power over what? 2 factorial. Okay, then we go the next term, which would be plus 128, x minus 0 to the third, that matches the third derivative, over 3 factorial, and then we would have finally minus 1536, x minus 0 to the third power, all over 3 factorial, like that, okay? Now, you can write this out a little bit, so actually what you would end up having is you would just, if you simplified this, you would end up having 4x is what that would be. Okay, right? And then this you could do, see that's 16 over 2. 2 factorial is 2, right? 2 times 1. So 16 over 2 is 8. So that would be minus 8x squared. Okay, like that. All right. Then if we kept going from here, what we would have is, okay, that's 128 over 6. Now what I'm going to do on this is I think I'm going to go ahead and, instead of simplifying this, I'm going to go ahead and just kind of look at powers, because we are going to want to finish this problem up, we're going to want to do a ratio test. We got to write a formula for this. So I'm just going to keep kind of writing it down as 128 x to the third, and then 3 times 2 is 6. I'm not going to reduce the fraction. Then I have 1536 x to the third, and that should have been a 4 factorial. No. Where did I mess up? 2, 3. Oh, here's where I messed up. That should be a 4th power, and that should be over 4 factorial. Sorry about that. Okay, so the exponents go up, so that would be 4. Let's see, 4 factorial is 4 times 3 times 2, so what is that, 24? So you'd have that. That would be your first 4 terms, like that, okay? Now, what I'm going to do with this is, on the next page, I want to kind of show you the second part. That's the first 4 terms. That's generally not that difficult thing to do as long as you can do your derivative. Now we're going to write that as a power series, okay? So on this next page, this is kind of what we just had, okay? Now I had the 16 over 2 is 8, so I had that kind of. So we're going to look for a pattern on this, and if you go out and kind of look at this, you have that 4x embedded in the problem. So this is really just kind of like this. This is like 4x to the first minus, okay, and then what you have over here is that whole thing is to the first power like this. If you look at this right here, what you have is you really have a 4x to the second to get that 16. Then you have all over 2 like that. Okay, then if you do the next thing here, and let's see, on this one, then you're going to have this. The next one you're going to have 4x to the third, okay, but see, 4 to the third is 64. 64 times 2 is 128, so you're going to have that. And that 6 is really going to be 3 factorial. And that 2 is really going to be 2 factorial like that. What I'm trying to do is trying to show you a pattern on this so we can write this as a series formula, okay? And you can play with your calculator a little bit on this, okay? If you do the next one, you're going to have 4x to the 4th power, and I'm going to do one little quick thing on my calculator. If I do this, if I do 4 to the 4th, then I get this, 256, but if I take 1536 divided by 256, I get something that has a factorial in it probably. That's what I thought. So that's going to be times 6. And then that 24 factorial is really 4 factorial like that. Okay, so what I'm doing is I'm kind of looking for a pattern when I do this like this. Okay, so I've got that. You guys see what I'm doing? Okay, you can even put a 1 factorial there if you want to. That's the pattern. I found the pattern. So what I'm going to do is kind of put this together. So I'm going to start with k equals 1. This is k equals 2. That's k equals 3. That's k equals 4. Okay, what we want to do is we want to see if we can write this in a series notation. Okay, like this. So let's think about what we have. Okay, just pick a term and put it together. Let's pick like this term right here, and let's just look at this and see if we can put a formula together. Well, the first thing you're going to have is 4x to the k power, right? If k is 4, that matches up. Okay, the denominator is going to be what? That's just what k factorial, right? Okay, you guys see what I'm doing? Okay, now how about this thing right here? That's actually a factorial. If you look at that, 6 is actually 3 factorial. 2 is actually 2 factorial. So that number that goes in front, if k is 4, then that's k minus 1 factorial. So you're also going to have that k minus 1 factorial in there. And see, now I've got everything accounted for. I've got everything I need. Okay, if you go to the next term, what would happen on the next term is you would have 4 factorial, 4x to the 5th over 5 factorial, and so forth, right? So everything matches 4x to the k, k factorial, but then that number is always 1 less than k. Does that make any sense? Okay, that's the series. Okay, so that is the Maclaurin series right there. Okay, that's the other thing I want you to be able to do. And generally, you can go through and look for a pattern in that, like that. Okay. Now we're going to figure out the interval of convergence. So to finish up this problem, this is probably all I'll have time to do today, is we're going to go ahead and just do the ratio test to find the interval of convergence. So we've done that several times today. So what we're going to do is we're going to do the limit, k goes to infinity, and then we're going to go ahead and when we do this interval of convergence, we're going to do absolute value of a to the k plus 1, a sub k plus 1 over a sub k. And we want to show that that's less than 1, like we've been doing. So let's go ahead and see what we can get done on that then. Okay, so that's going to give the limit as k goes to infinity of, write down the a sub k plus 1. Okay, so that's going to be 4x to the k plus 1. Okay, and then this is going to be, when you replace that k with k plus 1, you get k plus 1 minus 1 factorial. And then in the denominator, you get k plus 1 factorial like that. Okay, always the same drill. Make the term go up 1. Okay, then multiply by the reciprocal of what I gave you. So the original series, do the reciprocal like that, and then we'll see where that takes us. Okay, so a lot of these problems on ratio test, you have all kinds of cancellations and stuff that go on. So let's see where this leads us then. Okay, so let's see. I'm going to write this stuff out kind of carefully. So I'm going to put it all in one fraction. So I have 4x to the k times 4x to the first. Okay, this thing right here is just going to become k factorial because the 1's cross out. Okay, and then I've got k factorial there again, like that. Okay, denominator, I'm going to write it out. So we've been doing this a lot. How do you write out k plus 1 factorial? All right, k plus 1 times k factorial. Okay, then we just leave the 4x to the k alone. Okay, and then k minus 1 factorial. How do you write that out? K minus 1 factorial. Well, let's see. We could just say k minus 1, and then what's the term next after k minus 1? K minus 2, okay, and so forth like that. Okay, so that's going to go down kind of like that when we do that then, okay? All right, so let's see kind of what we have on here. I hope I got that okay. So let's see what cancels out on that and everything. So let's see. Seems like I may be missing something here. Okay, so that's going to cancel. That's going to cancel. And let's see, is anything else cancel? I don't think anything else cancels on this one. So I think I got missing some little thing on here somewhere. Because I was kind of getting in a hurry to get this done. So let's see.
Another one. K minus 1 factorial is k minus 1 k factorial? No. No, because that would be the pulse one. Oh, okay.
Shoot, what did I do?
Can't you turn that k factorial on the top into just a k and then cross out the rest of your terms on the bottom there?
Oh yeah, duh. Okay, sorry. I'm getting in a hurry. I see that we're almost out of time here. Yeah, okay, sorry about that. Yeah, this thing right here, okay? Yeah, so let's write this out like this, okay? All right, yeah, so k factorial, just write that out as k times k minus 1 factorial, okay, like that. Now what that's going to do is that's going to cross out that term and all the rest of the terms, like that. I should have saw that, but I just didn't see that. So what that's going to leave us then is the limit as k goes to infinity of, and it looks like we're going to be left with 4x times k. Then I've got k plus 1 left over like that, okay? Okay, that constant comes out, so you're going to have absolute value of 4x times limit, k goes to 1, of k over k plus 1. I'm going in super speed here, okay? What's the answer to that limit? 1. So that's 4x times 1, so we get that. So what we would do now is we take that 4x, we set it less than 1, and that would give negative 1 less than 4x less than 1. Divide everything by 4, so you would get an interval of convergence of negative 1/4 to 1/4 like that. Now, I'm not going to have time to test the endpoints, but I've done that a ton today, right? You guys know what I mean? Okay, so I'm going to see after you test the endpoints, you can verify the details out of class if you want to, you would actually end up with negative 1/4 not working, but 1/4 would. Okay, I'm not going to go through that thing. If I had time, I'd do that, but we did a bunch of that today. Okay, so that I wanted to get through one thing like that to definitely have you get that. And we'll wrap up just a few things next time and do some review next time.